Hi guys, this is Alicia with Good Morning Sunshine. I told you yesterday that I was going to talk to you about Neurobiology 5, which I will be doing right now. It's quite boring. We're trying to learn neurobiology over Zoom, which is kind of hard, and also his labs are over Zoom for the brain. It's very hard to learn that way and hard to learn over PowerPoint, especially because neurobiology is so hard. So it's been a process of trying to understand exactly what he's talking about. So we're going to talk about, I think I started this yesterday because I think he got to slide 5, but I'm going to reiterate what I said yesterday because I'm not exactly sure what I told you and I don't want to go back and listen. So we're going over the overview of the structure, function, and pharmacology of the autonomic nervous system. So what exactly is autonomic nervous system? There's many parts to it. You have the somatic part, which is the motor system part, and then you also have the autonomic, the visceral motor system. So one has effects on the external environment, while the other has effects on the internal environment. So the one that has effects on the external environment is the somatic skeleton motor system, and the one that has effects on the internal environment is the autonomic visceral motor system. The somatic skeletal one usually has to do with skeletal muscles, whereas the automatic one has to do with like blood pressure, heart rate, gastric motility, bladder emptying, and pupil size. And then usually the internal one has to do with homeostasis, which is the maintenance, of course, of the stable internal environment. So then we got into what are the major divisions of the autonomic nervous system and their functions. So there's two parts of the autonomic nervous system. We have the sympathetic part, and then we have the parasympathetic part. The sympathetic part gets the internal environment ready for emergency situations. So it gets all the energy ready in order for these stressful situations. This is the fight or flight division, whereas the parasympathetic is the restoration and conservation of energy in non-stressful times. It brings everything back to the baseline, basically everything back to homeostasis. And this division is known as the rest and digest division. So and then we have the enteric division, which we don't talk about much, but it's also another division. It's basically known as the second brain. It's again considered a third division of the autonomic system. It is part of the GI tract and the GI tract wall, and has a self-contained system of sensory and motor neurons that can independently maintain the GI function. However, the enteric division function can be influenced by the central nervous system by way of sympathetic and the parasympathetic divisions. So then we got into what are some differences between the somatic and autonomic visceral motor systems. The somatic is controlling skeletal muscle, like I said. It's usually conscious of these actions. Actions at peripheral targets is always excitable. There's only one synapse between the central nervous system and the peripheral target. And postganglionic neuron is what that synapse is called. The autonomic nervous system, the autonomic motor system controls cardiac, smooth muscle, and glands. It's unconscious to these actions. It's under no voluntary control. Actions at the targets are either excitable or inhibitory, and there are two synapses between the central nervous system and the peripheral target. So then we got into where do autonomic preganglionic neurons originate from. They are located in the thoracic and lumbar regions of the spinal cord. The parasympathetic ones are located in the gray matter of the sacral spinal cord. Also, some cranial nerve nuclei are located in the brain stem. Whereas the sympathetic preganglion are shorter, but the postganglionic neurons are longer. The sympathetic are located in the thoracic and lumbar region of the spinal cord and in the gray matter. And in this case, the pre are longer and the post are shorter in the parasympathetic. So in layman terms, the sympathetic nervous system, also called the thoracico-lumbar division, whereas the parasympathetic is called the craniosacral division. So the preganglionic autonomic neurons in the spinal cord are located in the intermediate zone, which is also called layer 7 of the gray matter between the dorsal and ventral horns. And I can show you here. So you have the dorsal horn up here, the intermediate zone, and then the ventral horn. So the preganglionic autonomic neurons are located in the intermediate zone. So dividing everything up, we have parasympathetic in the sacral region, we have the sympathetic in the thoracic and lumbar, and then the parasympathetic also in the dorsal motor nucleus of the vagus. So those are the cranial nerves that are in the brain stem. So where do sympathetic preganglionic neurons project for control of peripheral targets? The sympathetic preganglionic neuron synapse on the structure called the paravertebral chain ganglia, which is outside of the spinal column. We find aggregates of postganglionic neurons in the paravertebral chain ganglia. The postganglionic neurons control blood vessels, smooth muscles, basically the hairs to stand up on our skin, and sweat glands. The sympathetic pre are restricted to the thoracic and lumbar regions of the core. The paravertebral chain ganglia can run from the sacral to cervical regions. Therefore, the post neurons can run from sacral to cervical as well, and they supply many regions. So now we're looking at the more rostral pre-sympathetic regions. So the preganglionic to thoracic and cervical chain ganglia, post axons form own nerves to thoracic viscera or smooth muscle glands of the head. So then we then look at the caudal regions of the cord, where the sympathetic preganglionic are sending out axons toward the chain ganglia, but do not synapse with the paravertebral chain ganglia, but rather bypass them and then form splanchnic nerves. The splanchnic nerves will then synapse on the prevertebral ganglia. So then in scenario number 4, some of the splanchnic nerve axons are going to the adrenal glands on the kidney, so running into the core of the adrenal gland, the medulla. The chromafin cells can secrete epinephrine and no norepinephrine into the bloodstream. So then we got into where do parasympathetic preganglionic neurons project for control peripheral targets. Sorry, I'm just trying to get to the right slide. But pre-neurons are located in the cranial nerve nuclei, like I said before, of the brainstem, or in the gray matter of the sacral spinal cord. The cranial nerve nuclei, except dorsal nucleus of vagus, send axons out to autonomic ganglia in the head, and they supply the visceral structures that are in the head. The dorsal nucleus of the vagus pre-axons wander down to the thoracic and abdominal cavity to synapse onto postganglionic neurons that are close to the abdominal visceral organs. So how can organs be controlled by both sympathetic and parasympathetic innervation? Well, he said the thoracic lumbar sympathetic preganglionic neurons can respectively activate postganglionic neurons throughout the more extensive sympathetic trunks. The postganglionic neurons of the extensive sympathetic trunks can then activate cranial and pelvic viscera in addition to thoracic and abdominal viscera. The craniosacral parasympathetic preganglionic neurons can respectively activate parasympathetic postganglionic neurons controlling the head and pelvic viscera, but the parasympathetic preganglionic axons from dorsal nucleus of vagus wander to thoracic and abdominal cavity to control the viscera there. So then we got in, what are the neurotransmitters of the autonomic nervous system? All of the preneurons are going to release ACH. Post of parasympathetic also release ACH as their neurotransmitter. The sympathetic release norepinephrine, which is NE, and ACH via acetylcholine. And then what are the neurochemical receptors of the autonomic nervous system? Like I said, you have ACH, you have a lot of things. So you have the nicotinic acetylcholine receptor, which is N. You have M, which is the mescarinic acetylcholine receptor, and then you have alpha adrenergic receptor, and then you have beta adrenergic receptor. So then that's basically what we learned in Neurobio 5. It's a lot of stuff that I have to put together still. He switched a few slides, so I also have to go over those too, which I didn't explain. But yeah. Just prepping for Monday. We have a long week next week, and then of course testing the following Monday with our lab exam and written exam on the same day. I currently have to make flashcards and stuff so I can start retraining information so I'm not backed up. I feel backed up right now, but it's just a lot of information, but we will get there, right guys? Right. I hope you guys are having a good weekend. I'm trying to have a good weekend before I die next weekend, studying for the 2 exams. But I love and miss all you guys. I can't wait to see you guys in December. I know it's still a long ways away, but I'm going to keep looking forward to it. Because I'll be driving down with my dogs, so I'll get to see a lot of you. And especially my girlfriend, and my brother, and his wife. So, yeah. Well, I love you guys, and I thank you guys for watching.